Alright, welcome to today's class. Still on the algebra of complex numbers. In this class, you are going to be considering the multiplication and division of complex numbers. Now, take note of this. I is equal to square root of minus 1. Now, I squared becomes square root of minus 1 all squared. So, square root cancels square. I squared is equal to minus 1. Now, I raised to power 3 is equal to minus 1 all raised to power 3. So I raised to power 3 is equal to, this can be written as minus 1 raised to power 2 multiplied by square root of minus 1. So I cube becomes square root of minus 1 all raised to power 2 give us minus 1. So it is minus 1 and then multiply by square root of minus 1 is I. I is equal to square root of minus 1. So we substitute I here. So it becomes I. So therefore, I raised to power 3 is equal to minus I, because minus 1 multiplied by I is minus I. Now, so let's look at I raised to power 4. I raised to power 4 is equal to, it can be written as square root of minus 1, which is I, all raised to power 4. So I raised to power 4 is equal to square root of minus 1 all raised to power 4 can be written as square root of minus 1 all raised to power 2 multiplied by square root of minus 1 all raised to power 2. So therefore, I raised to power 4 is equal to square root of minus 1 all raised to power 2 give us minus 1. So this is it. It gave us minus 1. And then multiply by minus 1. So I raised to power 4 is equal to minus 1 multiplied by minus 1 is positive 1. So this is for I raised to power 4. So let's find I raised to power 5. I raised to power 5 is equal to minus square root of minus 1 raised to power 4 and then multiply by square root of minus 1. Remember that square root of minus 1 is I. So now, I raised to power 5 is equal to square root of minus 1 all raised to power 4 give us 1. I raised to power 4 is 1. So it gave us 1. So we substitute 1 here and then multiply by square root of minus 1 is I. So here we have I. So I raised to power 5 is equal to I. Alright, so let's take a practical example. Simplify 3 open bracket 2 plus 4i We are asked to simplify this. Our first task is to open up the bracket. So if we open up the bracket, we use 3 to multiply the terms inside the bracket. So 3 multiplied by 2 is 6. And then plus 3 multiplied by 4i is 12i. So this is our answer. Let's take another example. 5 plus 3i multiplied by I. Alright, so let's solve this. Our first task is to open up the bracket. We'll use I to multiply the terms inside the bracket. So here we have I multiplied by 5 gives us 5i. And then plus I multiplied by 3i gives us 3i squared. So this can be written as 5i plus 3 multiplied by I squared. Now recall that I squared is equal to minus 1 from our previous calculation. So now let's substitute the value of I into the equation. So we have 5i plus 3 open bracket minus 1. So 5i minus 3, because 3 multiplied by minus 1 is minus 3. So 5i minus 3. So now let's rearrange. So we have minus 3 plus 5i. We have to rearrange it because the real term comes before the imaginary term. So this is our final answer. Alright, so let's solve another example. If z1 is equal to 2 minus 7i and z2 is equal to 3 plus 4i, and we are asked to find z1 multiplied by z2. How do we solve it? So here, z1 multiplied by z2 is equal to 2 minus 7i multiplies 3 plus 4i. So z1 multiplied by z2 is equal to, now let's open up the brackets. We'll use each of the term in the first bracket to multiply the second bracket. So here we have 2 open bracket 3 plus 4i, and then minus 7 open bracket 3 minus 7i rather open bracket 3 plus 4i. So here we have 2 multiplied by 3 is 6 plus 2 multiplied by 4i is 8i. Minus 7i multiplies 3 gives us minus 21, and then I. And then minus 7i multiplies positive 4i. It gives us minus 28i squared. So here we have 6 and then minus positive 8i minus 21i. We are left with minus 13i and then minus 28i squared. Now recall that I squared is equal to minus 1 from our previous calculation. Now let's substitute minus 1 into the equation. So we have 6 minus 13i minus 28 multiplied by minus 1. So here we have 6 minus 13i and then plus 28, because minus 28 multiply minus 1 is positive 28. So now let's collect like terms. So here we have 6 plus 28 and then minus 13i. Finally, 6 plus 28 is 34. So we have 34 minus 13i. So this is our final answer. Alright, so quickly let's look at the conjugate of complex numbers. Conjugate of complex numbers. Conjugate of complex numbers. The conjugate of complex number is obtained by changing the sign of the imaginary part. So if z is equal to a plus bi, and we are asked to find the conjugate of z, what do? The conjugate of z is written as this: z and then a bar at the top. It is equal to, you change the sign of the imaginary part. The imaginary part here is bi, and the sign attached to it is positive. So it becomes a minus bi. Let's take another example. If z is equal to 2 minus 4i, and we are asked to find the conjugate of z. The conjugate of z, which is z bar, is equal to 2 plus 4i. Just change the sign attached to the imaginary part. That is what makes it a conjugate of a complex number. To find the conjugate of a complex number, simply change the sign of the imaginary part. So this is our final answer.